Okay, I think we can start. Hello everyone. Welcome to Meet a Data Scientist, a mentor session with Mr. Joseph Stiehm. And yeah, we're super glad to have you today.
All right. Thank you very much, Nilesh. I appreciate the invitation. Um, it's, I was telling you that, when you made the offer, it was I was thinking to myself, well, do I know enough about data science to actually present to a group of high schoolers? And I'm thinking to myself, well, so I've been doing this for over 2 decades. So if I don't have enough expertise now, I don't know when I will. So, in any case, I'm happy to be here, happy to present. My interest today is to provide you a glimpse into what data science is. Talk a little bit about myself in as much as want to provide you kind of a concept of how I got to where I am, but also then to provide you an idea of what I do in order to be successful. In other words, what I do in terms of A/B testing. My current role is that of a senior data scientist at Adobe. As a senior data scientist, what I involve myself in is primarily A/B testing, and I'll go into a little bit about what A/B testing is. But I do that with respect to our flagship Creative Cloud app, which is Photoshop. Prior to my stint at Adobe, I've been here about over 4 years. I was also at Cisco Systems for a couple of decades. And I've had a number of roles during that process. And I'm going to go into that a little bit later. You may be interested in understanding kind of the technologies that I engage in. And I can talk a little bit about that. But what I want to talk about first is just talk a little bit about what it takes to be an expert. There's this clever quote by Niels Bohr. Niels Bohr, the physicist of the mid 20th century, and talked about how an expert is a person who has found out by his own painful experience all the mistakes that one can make in a very narrow field. And the reason why it speaks to me is talking about the nature of error as it relates to expertise, and how it is error itself which allows one to build and to be able to recognize one's capacity for learning from those errors, but also for teaching someone else not to make those errors. And so it's when somebody comes to you and says, I've got this great idea, and you can say, I've tried that 15 different ways and none of them works. That kind of sets you apart from somebody who's new to the field. And so, just as a group of young people who are kind of learning by their own trial and errors on all sorts of different topics, recognize that leads into a whole host of professional activities where you learn by those errors. But just realize that errors are not, in effect, the challenge. Errors are the foundation of your path forward. It is not just making the errors, but learning from those errors that you get to where you're going. Wow. And when we talk about errors, specifically to A/B testing, and I'll talk about that a little bit, it has actually an interesting role because we actually have negative tests. Negative tests are ones that are, in effect, positive, just to let you know. I want to share with you something, because data science can be talked about as applying statistical methods to large swaths of data to be able to extract intelligence from that data. And one of the reasons we talk about it as a science is because it involves experimentation. It can be very exacting. And the reason why it needs to be exacting is because it's easy to go wrong with statistics. It's easy to make bad inferences based on naive understandings. I present this example here of Simpson's paradox because it is one which will capture the interest of a lot of people. It's one that is not, it's counterintuitive. And so we take a look at an example here of two airlines, and we look at their on-time, their on-time rate, right? How often they're delayed. And you compare this on an overall scale, and you see that Alaska Airlines has a delayed rate of 13.3%, while America West 10.9%. Now, if you're saying to yourself, well, I absolutely need to be there on time every time I use a particular airline, you might well be able to say, well, I will choose based on this America West. Paradoxically, name of the name of Simpson's paradox obviously comes from this. You look at it on a per airport basis, and in each case, you can look through them, but in each case, Alaska Airlines actually has a better performance in comparison to America West. Now, you look at this, and somebody who's new to statistics, somebody who's trying to answer the question, which airline do I fly? This might leave them a little flummoxed. How is it possible to get two different contradictory results from these statistics? They're merely weighted averages. This should, one asks naively, this should give rise to the same general trend. Now, that's one of the interesting facets of statistics. And in particular, what we're seeing here is that if you choose to make a decision on America West overall, you can still find yourself in a negative circumstance. So the question is, how do you resolve this? And one of the ways you resolve that, or one of the decisions then you come to, one of the realities that you realize is that it is in subdividing the data that you can gain further intelligence. That a surface investigation is often limited in terms of how you can appreciate the nature of the information that you're looking at. This is something which happens time and again, and I can share a recent situation that I engaged in terms of the use of statistics as it applies to data. But bottom line, as we're going through here, what I'm going to share with you is how we investigate not just surface level metrics, but how we also look at subsectors. In this case, what we do, what someone might well do is say, okay, well, now I have to concern myself with each individual airport and look at that rather than just looking at overall. Now, the curious among you might well say, well, if you looked at it this level, is that necessarily kind of the ground truth? But it's true that, say you wanted to now look at it not just at a per airport basis, but you looked at it at a per hour basis, it could flip again. Bottom line here is that statistics is not necessarily, as opposed to say probability, statistics has more art to it, or as much art as science. And the reality is that you have to continue to ask the questions. It's not I've reached my destination. It's a matter of, I've gotten these results. This is what this is telling me. These are maybe further avenues of investigation that we have to take a look at. All right?
Yep.
So when we talk about data science, again, it's the application of scientific methods, investigating science. So what we do is, we develop hypotheses. We do some hypothesis testing to try to derive intelligence from the data, right? I use the term intelligence as opposed to distinguishing from data, because when we talk about raw data, it's just numbers. It's just facts. But when we talk about intelligence, it allows one to make decisions based on that intelligence. Data science is not, it's not monolithic. It involves a number of different, subcategories with respect to skill sets. You're going to find people that just do data engineering that just do machine language algorithms, that just do storytelling. Now, reality is that in a lot of cases, a data scientist will do a mix of these things. But within a team, what you'll find is that within a data science team, you'll find that some people are data engineering experts, other people are data visualization or BI experts, and other people engage in storytelling. Some people naturally gravitate to being able to get in front of groups and just start talking about their results. Just to let you, so I'm going to go through these and then I'm going to talk about a little more about these in detail. So data engineering involves building pipelines. So we have data that's being ingested from systems. Well, so in my case, what you have is people using software and they're sending anonymized telemetry. And what we want to do is we want to collect that and analyze it and be able to derive intelligence from it. In terms of machine learning algorithms, we have people who, after you pull that data in and convert it from trillions of bits of data to millions of bits of data, what we do then is we apply machine learning algorithms to them to be able to understand clusters of use, right? Data visualization expert will be familiar with Tableau, Power BI, some other visualization tool. These are applications which we use to be able to provide bar charts, line charts, different visualizations that, depending on the data, make more sense in terms of how they're presented. The data visualization expert will know how to pull in that data and be able to present it effectively. Across this, obviously, we have to have people who know the business. In my case, it's knowing software business. But in other cases, in terms of data science, it might be medical knowledge. Other people might need to know financial knowledge, stock market, what have you. Without that knowledge, you've just got a bunch of data and it's really hard to be able to extract intelligence from it. Without that contextual knowledge, you don't know the terms that people use. You don't know why, for instance, you sell this to this group of people at this particular price. Without that information, the problem is trying to understand how you should change, how you should do things differently is very hard. So business knowledge, which you get from experience, is something which is essential in most of these areas. But then finally, you also have storytelling. And mind you, there are other things outside of this that'll probably that others would include in terms of data science skill sets. But this is my subdivision. And storytelling really is talking about how you explain to an audience, how you talk at the right level. People who are you might talk to a bunch of technologists, people who are invested in the data, in a different way than you talk about, for instance, directors or VPs. VPs want to know the facts. They want to know, if I do this, will I make more money, right? And so depending on your audience, you have to tailor your discussions and you have to be able to change your message in order to be able to talk to them. Just going a little bit more into detail into these, data engineering involves, pulling a lot of data from these big systems. Again, sometimes in terms of trillions of data. If you're talking about in terms of data from NASA or whatnot, you're talking about petabytes, maybe exabytes worth of data that is being drawn down. What a data engineer will do is they'll generate a pipeline which will take that data and then move it, transform it. Maybe they've got at least a couple of systems or multiple systems. I remember I did one job. We were pulling data from a dozen different systems. Bottom line is you have to pull that together. You have to relate it to each other. Then you have to reduce it into something that can be easily operated on. Because even though we've got really impressive computers these days, trying to operate on, a trillion record data set, very difficult. And so what we do is we massage this data, we transform it, we aggregate the data. So instead of dealing with a million records, each with one event, we might say, all right, we're going to compress these just to one record with a number of a million events is in one of the fields. So bottom line, we compress it, we relate it, and then we reduce it so that now we can apply machine learning algorithms to it to be able to gain intelligence from that. And that's what a data engineer does. The person who specializes in machine learning algorithms, well, they will then take a look at that data and they'll operate on it in terms of looking at various patterns within it. And so looking at those patterns, they'll apply certain algorithms to them in order to be able to understand those patterns. One particular pattern that you're looking at right here is clustering. So what we're looking at is a hypothetical data set where you're looking at customers along two different axes. One is their annual income, and one is how much they spend. And so what we can do is we can take that million record data set, throw it in here, looking at those two dimensions of data, and say, where do our customers lie primarily? But more importantly, are there groups based on these dimensions that allow us to target them in certain ways? We take a look at these folks that, for instance, have a higher income, but they have a lower spending score. So maybe we target them, offers to them in a slightly different fashion than we would to somebody who has, for instance, a lower income, but higher spending score. Maybe what we do is we present to them, say this is online, we present to them an offer that says, you can get this bling. It's not it doesn't cost a lot, but or maybe it does cost a lot. But the point being that these people are going to have a higher propensity to spend, even though at lower income, they might be buying different things. And so we might want to target different offers to them. That's some of what we do with respect to data science is we try to understand the behavior of our systems in order to be able to operate effectively. And feel free to, ask questions at any point. I mean, I don't want to drone on and on. So we will have Q&A, but I encourage you to raise your hand if you have any questions about what I'm presenting on. I want to talk a little bit about A/B testing at this point, because that's one of the things that I do right now. A/B testing comes from the term comes from being able to take a sample of users. In this case, I'm talking about software testing. So we're talking about is taking a sample of users and separating them into two groups. We call those groups A and B. So you'll take 50% of the groups and put them in A. We'll take another 50%, put them in B. A will be the control group, which means they'll get the normal intervention, which is, when they click a particular button, they'll get the normal response, the one that everybody else gets. No change to that. Group B, however, will have something that changes it slightly. Maybe the button will be bigger. Maybe it will, spin. Maybe it'll come with a little notification saying, do you want to do this? Bottom line is, what we're doing is we're testing in the way that a scientist would the behavior of the control against the test subjects using a particular measurement to determine how effective it was. Let's say what we're trying to figure out is we want to get more people to save their files. Why do we want them to save their files? Because if they don't save their files, maybe they lose something. I'm using a hypothetical example. Most systems have autosave at this point, so it's not a particular situation. But that would be one way to resolve things. I want to prompt you to save periodically in order that you don't lose your information and in order that you're a happier customer. So I'm going to measure based on, how often you save. I'm going to measure the effectiveness of the test. And so what will happen is I'll run this test. I'll check to see based on these equal size samples, and they're random samples, right? So I don't want to take everybody from the West Coast in sample A and everybody in the the East Coast in sample B. I'm going to want to make them certain that they overlap so that it can be scientifically accurate. And what I'm going to do then at the end of this test is I'm going to say, okay, did the people in test save more often than the people in control? And if they did, and if it was statistically significant, which means it wasn't just because we're going to find a lot of variation. So in data science, what we do is we take a look and we evaluate it for whether or not it's likely due to chance, or does this actually say, no, these people probably did click this button more often because of this test, because of this intervention. And based on that, then we'll derive some results. And if we say, all right, we're satisfied with this, it's leading to some positive results, we may push it into production. So now everybody gets it. That's a lot of what I do. A lot of what I do involves kind of looking at things that we want to have happen more often, and then devising a test to make that happen. Once we do that, well, we iterate, which is to say, how do we make this better? How do we affect a different group? Because as I was talking about before, this is kind of a situation where you can look into subgroups and see if it affects one subgroup better than another subgroup. And so that's a lot of what we do from what I do from a day-to-day basis. But now I want to continue in terms of some of these other things that we do. Data visualization is somebody who specializes in taking the data and representing it in a way which speaks to the audience, right? So here's something where, we're looking at conversions by country, but it could be sales by country, what have you. But you take a look at the different colors and we color code it based on this type of a map. But we also have this type of visualization. We are all familiar with the line and the bar charts and whatnot, but you also have this donut chart here. Bottom line is visualization is an art form in itself to understand the data that you have to present. How do you present it effectively to the audience? And then one thing we don't spend enough time on talking about is the soft skills. Soft skills is actually something which is hard for a lot of people. I know that a lot of people who delve into technology, and I don't know if you guys feel the same way, a lot of people feel as if, talking in front of groups is not something that they're particularly comfortable with. I am not someone who, I would not consider public speaking my favorite thing to do. So just to let you know, I have worked very hard to improve, but my reality is I'm much more comfortable in the data than I am in terms of presenting it. But the person who's good at this knows their audience, knows what they're looking for, knows, for instance, if they're talking to VPs, it's different from talking to a bunch of technologists. And they will then understand the business, understand what the business seeks to gain, understand what that group wants, and be able to present the information at a particular level using the particular intelligence that is appropriate to that group. And so storytelling, creating the narrative from that intelligence, from that data, is an important part of what makes a data scientist. And it's one that's not spoken about enough. So that's kind of what I wanted to share with respect to, what a data scientist does. My own journey starts back at Cisco 28 years ago. I started working as a report developer. So it was not data science, it was more data analysis. Report developer. I segued and I did a whole lot of different things. I did some object-oriented development in Java. I did some data modeling. Data modeling, what it does is it seeks to understand what your data looks like, and then it models it in a database. So for instance, if I have a bunch of people and I want to store their names, their addresses, and how much they purchased, I might create separate tables for people, addresses, and sales, and then connect those together. So data modeling, there are different languages that I had to learn along the way, including SQL, which is the structured query language, which is the most common way that we currently pull data, extract data from a database for further processing. Python, which is a language which is used to do kind of statistical inferences around the data that we find in these databases. And then along the way, I also learned some of these visualization tools like Tableau and Power BI. But what I find is that probably every 5 years, my role has changed. I've not gone more than 5 years without having some significant modification to my roles and responsibilities. And that is by choice, which is that what you're doing, you're going to find yourself 10 years from now in a career. What you're doing then, and I'm not saying that you can't, be an insurance adjuster your entire life. I mean, that's fine. But what I'm saying is that in technology, it changes at a quite rapid pace. And so what I've found is that I will have a need to understand what the landscape is going to look like 5 years on, and project myself. Where am I going to be 5 years from now? It's just a consistent effort of mine to try to be able to provide a certain predictability to my own life, applying perhaps some data science methods to my own life in terms of my career. It's not just purely intellectual satisfaction. It's not purely to avoid boredom, but it's also to know what is going to be a necessary, what kind of job is going to be necessary, 5 years on, and how things are going to change. The term data science itself, I mean, I came to know about in 2010s, but like most of these things, the term actually developed from the 1960s, 1970s. So, during the mid 20th century, all of the foundations for these things in terms of their statistical basis, statistical foundation came into play. But I came to know about it in the 2010s, and I gained my certificate from the University of Washington in data science while working at Cisco about 10 years ago. Since then, I worked in an effort around natural language processing. Natural language processing involves taking data in human readable format, just normal data, and be able to process it. I mean, if you've ever taken a look at Google Ngrams, right? Looking at the frequency of words within a corpus, within a body of documents, you understand a little bit about natural language processing. It talks about being able to subdivide these things and being able to understand the frequency of these terms. And I used that to try to look at where our assets were being maintained. But more recently then, looking at my work at Adobe, for the past couple of years, I've been working in terms of A/B testing. What will I be looking at 5 years from now? What is the world going to look like for you guys 5 years from now? Will I be doing data science in the way that I am now 5 years from now? Well, we're seeing the influx of, large language models into our work streams. How we do our work today is changing. What I will tell you is that a lot of people are saying, what, AI is going to get rid of our jobs. And one of the truths that I hear that resonates is that we overestimate the impact of transformative technologies in the near term. We underestimate the impact of these transformative technologies in the long term. What that means is that over the course of 5-10 years, things may not change as much as we expect. Over the course of 20 years, 30 years, it may change much more radically than we expect. So as you're looking towards the future, as you're looking to understand, what do I want to do? Number one, make certain that you're keeping an eye on the landscape. So I look and I read journals. I look and I listen to YouTube around data science. I keep my ear to the ground with respect to the areas that, number one, I have a passion in. And by passion, I mean I was doing database. I started when I was in about your age. I started by developing databases of my favorite movies. So what I did was and these were very primitive databases at the time. What I did was I had these VHS tapes. If you don't know what a VHS tape is, talk to your parents. But bottom line, I had these VHS tapes that I recorded a lot of movies on, but I needed to be able to reference them. So I created a database and I hand typed in the names of the movies, the actors in the movies, the reviews in the movies. I put this together because I was really interested in movies, but I was also very interested in technology. And so what I did at an early age was married two interests, two passions. And that has sparked a lifelong journey for me. Uh, you will almost certainly not follow the same path that I did. Mine was very circuitous. So, but what I did do and what may be common, what I would advise you to do is just to make certain that as you're applying your passion, make certain that you're keeping abreast of the way things are changing and make certain that you can apply your passions in a way which is one which will satisfy you. And so there's a point here that has to be made, which is that some people make, which is, you have to have a passion which, can also serve a financial end for you. And there's something to that. But then, some people say, well, no, you want to have passions and then or you want to have something that you work for and passion separate so you don't get bored of your passion. I will say that for me, data has been a lifelong passion and it has allowed me to do what I do. And so I don't know that I buy too much into the idea that you shouldn't work at your passion because you'll end up burning out or you'll end up hating your passion. But what I would say is for you as you're heading into this area, whether or not you want to do this, it really does matter as to whether or not this is something that you can do day in, day out without driving you up the wall. I mean, if you're into data, if you're into programming, if you're into, I see every day as Sudoku, but one which deals in software and what people are doing within the particular product and how we can better serve them. So it's a little puzzle for me every day to go in and kind of figure out what we're doing. And I hope if that is your passion as well, I hope that this area of study serves you well.
Cool. Thank you so much. Do you want to move into the Q&A now?
Sure. Mm-hmm.
So, yeah, everyone. So if you guys have any questions regarding what Mr. Stiehm said, or any questions related to data science, you guys can go ahead. Dennis, yeah, would you like to?
So obviously you talked about how like you feel about AI in the future for your job market, but I was curious as to how, like, let's say someone were to go into data engineering right now, how do you feel the job market would be for them, like in the present right now?
Well, so we've got a couple of themes going on right now. As I understand it, data engineering currently today is a little soft in the Bay Area. At the same time, I think that's I'm not. I don't have privileged knowledge here with respect to this, but I think it has to do with the groundswell in terms of being able to leverage AI. And I think what you're seeing is a lot of companies possibly changing their bets. But in changing those bets, that means that they're going to have to staff up in order to be able to satisfy those AI needs. And those AI needs will include quite a bit of data engineering. I don't see that letting up. I mean, I don't see that the core skills within data science, including data engineering, is going to let up anytime soon. Will it change? Most certainly. But I think it's going to change more gradually than people expect. I right now am, I've tried to leverage some of these AI, ChatGPT, what have you, to my work, and I recognize that part of the challenge is that they're just not there yet with respect to, for instance, writing SQL. They don't understand the subtle context with respect to some of these issues. Will it be resolved? I suspect it will. In what kind of time frame? I don't have a crystal ball, but I think that people studying today will find a healthy job market for AI. That's my expectation.
So, do you think that AI is going to be required for a lot of data science jobs in the future?
Almost certainly, yes. I think what you're going to find is that people will want to know how you leverage the tools to make yourself more efficient. My own perspective on AI is that it will augment us rather than replace us. It will be a force multiplier. Now, someone might well say, well, okay, well, then you just need one job instead of 10. Well, I think the reality of the situation is that companies will always want to be able to look for more, more profit. And so if they can find 10 engineers, right, that can do 10 times as much, then I think that, and they've got the funds to do that, then presumably they would prefer to do that as opposed to just replace 10 engineers with one engineer. So, I believe that if you're today, if you're looking to be marketable in the future, I think that understanding how AI can make what you're doing more efficient is critical to distinguishing yourself from the group.
Does anyone have any other questions? Okay. I actually had another question.
Mm-hmm.
I was wondering, as high schoolers, and I know you had your own unique path, being interested in data and working with VHS tapes and whatnot. As high schoolers now, what kind of paths or what should we do in order to get into data science and have a successful career in it?
Okay. So yeah, I'll tell you what. I had a lot of interest in mathematics when I was a kid. I loved geometry. I loved calculus. I loved number theory. One of the ones that I did not like, that I did not care for, it was a problem for me. It was probability, and more than that, statistics. Didn't like statistics at all. It was counterintuitive to me. There were so many things within statistics and probability that I thought it would go one way, but it went completely different, and it perplexed me. I did not get into statistics until I was in my 30s. I see now in the high school that my kids go to that they allow for not just calculus in high school, but also statistics. And I don't think that was offered when I was at my age, when I was in high school. And so I would encourage you to look into if data science is something which appeals to you. If you look at data science and you say, "Geez, I would love to get into that type of field," I would say invest yourself in statistics. That doesn't mean don't ignore calculus, but statistics will be an important keystone to your future development. As a data scientist. So statistics is one thing. Outside of that, obviously just programming in general. You don't have to be a programmer. I loved programming. I mean, I would lose days programming. And so there are people who in data science who program as a necessity, but they will. But I just think that computer programming is a necessary step in any person engaging in STEM today. And so you're going to have a foundation in computer science in order to be able to engage. So statistics, computer science. Outside of that, being able to think critically, logically, scientifically about topics of interest.
Okay, we have a couple more questions. But Kirsch, would you like to ask?
What do you think the future of data visualization will look like? Like now, how AI has transformed the world and has taken it by storm.
Yeah, data visualization. That's an interesting one. I see. Going back to my previous use of ChatGPT with respect specifically to Power BI, because I had a particular challenge with Power BI, and it completely failed. I spent better part of a couple of hours trying to kind of tell it to ask it how I should do something. And it was my first experience with hallucination, because in asking ChatGPT, how do I do this within DAX, which is the language of Power BI, it hallucinated a particular function signature that didn't exist. It said, just use this particular function, give it these parameters, and you're golden. Well, that function, that signature did not exist within Power BI. So it was very interesting. It was fascinating to me at the time. So what is the future of, AI with respect to visualization? I think the challenge exists with everything else, which is that we need to be able to develop AI, which is more robust.